Assalamualaikum warahmatullahi wabarakatuh. My name is FARHAD SYED ILHAM. So today we'll be continuing Lab 2 Operational Amplifier for comparator and summing amplifier. So comparator is usually used to compare the voltage amplitude, and the output can bring up two state. The output depend on the state which relations to the voltage in. So usually there is if voltage reference is more than voltage in, or voltage reference is less than voltage in. So for comparator today we'll be going to discuss about zero level detector and non-zero level detector. So for zero level detector, I already make a circuit here. So whenever the voltage reaches to zero, the output is produced, which is amplified, and it brings out a new wave, which is the square wave. So the value has increased from 10 volt to negative 13. Actually it should be more because we are using a 15 volt VCC, so the output is cut off to less than 15 volts. So next is zero level. So for zero level, for zero level we have to calculate the voltage reference first. So like here, for 4.7 kilo ohms of R1 and 1 kilo ohm of R2, we have a RF of 10 ohms. So after calculating using the formula given, which is this one, using this one, which is, so R2 is 1 ohms and R1 is 4.7 kilo ohms, and we times with VCC positive, which is 15 volts, so we get around 2.63. So after I did the simulation, so we got whenever the voltage reference, so I got around 2.73, which is close. So whenever it reaches here, as you can see, the square wave goes from maximum, positive maximum, to negative maximum, which is negative 15. So positive maximum is, as you can see here, is 15 volts. So for positive maximum, see, positive is 15 volts. So after it reaches the point here, it will become negative 15 volts, because the V reference is at 2.63 or 2.73 in this case, so it's close here. So see, whenever it reaches that point, it will become from positive maximum to negative, or vice versa. So next, for 2 kilo ohm R1, so 2 kilo R1, after we calculate, we get 5 volts. So for non-level, there is a rule. So for V reference is more than V in, the voltage will become positive. So as you can see, whenever the V in is more than reference, it will become positive maximum. So whenever it below voltage reference, it becomes negative maximum. So this is the same case for this one. So for this one, since we got 5 volt for V reference, it will never go more than 5 volts, because we only input 5 volt of the input of the voltage input. So the output is stuck at negative 15 volts, because that is the maximum of negative output for our circuit, so it will stay here. So next is 1 kilo ohm R1. So 1 kilo R1 is also the same, because after we calculate, the V reference is 7.5. So our circuit cannot go beyond 7.5, so it will stay at negative maximum until we change the V source. So next is summing amplifier. So what is summing amplifier? Summing amplifier is a amplifier that can add two voltage source. So that is why it's called a summing, because it's adding up the voltage of the amplifier, of the source. So in this case we have 1 volt and 1 volt. So okay, we have two types of summing amplifier. One is unity gain, which where all the resistor here is the same as the voltage, the RF, which is in this case is 10 kilo. So as you can see, all of this is 10 kilo ohms. So this is unity gain. So for unity gain, we can get we use this formula, V in plus V in 2. So since we have only two, so V in 1 and V in 2, we only add up those two. So we get negative because we inserting it to the inverting input. So we get so it should be inverted, the output. So since we inserted 1 volt, so okay, negative 1 volt should be 2 volts, because uh, inverting, like I said. So if we want to follow the calculation, so as you can see, let's see, so 1 volt of input will become negative 2 volts of output. So that's how summing amplifier works for unity gain. So this is not unity gain. The As you can see, the resistance is different for R2, R1, and R1 is still the same as RF. So this is different. So as you can see, so for R1 we can use the same formula. So we will get V in 1. So we get V in 1. But for V in 2, we have to divide RF divided by the resistor that is not the same as RF. So for this case is R2. So RF is 10 kilo and R2 is 2 kilo. So we times that by 1 1 volt, so we get 5 volts. So we should get negative 6 volt when the input is positive. So this is input positive, so 1 volt, and we get around negative 6 volts. So this one is for summing amplifier when the resistance is different than the RF. So next will be I'll be answering the question. So what do I understand about summing amplifier? Summing amplifier is a amplifier that we use to add all the voltage source that is connected to the amplifier, uh, which we can use summing amplifier unity gain, which is easier because we don't have to calculate the gain, we just add up all. So for if we don't use unity gain, we have to use the formula that was given just now, RF over the R value times with the V in, which means gain times with the voltage to get the voltage value that we will add up later on. So what happened to the output if the frequency of the sources is increased to 3 kilohertz? So when we increase the sources to 3 kilohertz, the wave will change. The distance or between the as you can see, the distance between the gap between will change because we're using one frequency is 1 over time. So here is time. So when we increase the frequency, the time gap will become smaller, so which will cause the sinus wave to become more compact and closer. So that's all. So for conclusion, so today I was able to learn how comparator and summing amplifier works. So as we can see that comparator has two modes, which is zero level and non-zero level. Non-zero level will depend on the V reference, and zero level will depend on the zero 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 point of the waveform. So for summing amplifier, as you can see, I was able to understand that how it worked, how it added up from the input, from the resource, that becomes the output, which is the sum of all the source, the input source. So that's all from me. So thank you very much for listening. Have a good day.